Now there are two types of states. One is the pair state and the other one is the mixed state. So what is pair state? Pair state represent systems for which we have complete information about their quantum state. How to understand this pair state and mixed state? Let's take some examples. So first, the pair state, we have defined that the pair state represents systems for which we have complete information about their quantum state. We will know about the quantum state and we have all the information about this quantum state. For example, a number state or Fock state. For example, a number state or Fock state. For a number state or Fock state, we must know about the number of photons. This can be described by n, this state, n state, where n is the number of photons, where n is the number of photons. Let's take this very easy. Let's suppose we have a single photon and we know about all the information about this single photon. Then for a single photon, we must write the state 1. So we know all the information about this quantum state. So this is known as a pair state. And the density matrix for a pair state must be written as rho, which is equal to, for a single photon, we must represent this as 1, 1. But if we have many number of photons and we know about these photons, then the density matrix must be written as this. If there is no any photon, then this is known as vacuum state. And for a vacuum state, we must write the state as 0. And the density operator must be written like this. So for a single photon, we know about the quantum state. So the density matrix can be written like this. And if there are many number of photons and we know about the quantum state, then we must write this in this form. And for a vacuum state, we must write the density matrix. So all these are pair states and we know about the quantum state. Another example is the coherent state. A coherent state represent the classical light such as laser light. So if we have a laser light, there are many number of photons, and the coherent state can be represented by alpha, this alpha, and alpha is the complex number. This alpha complex number, and this complex number represent the amplitude and phase of the electromagnetic wave. This alpha represent the amplitude and phase of electromagnetic field. And the density matrix for a coherent state must be written like this. So this is the density matrix. And we have all the information about this state. So this is known as the power state. Further example are squeeze state, polarization state, superposition state, and entangled state. All these are known as power states. So what is mixed state? I have written this state represents a statistical mixture of different quantum states where we do not have complete information about a system. So this is important. This is the difference between a power state and a mixed state. In a power state, we know about the quantum state, but in a mixed state, we don't know about the quantum system. But we know probabilities for various power states. So what will be the example of mixed state? If you suppose the sunlight or the usual ordinary light, there are many number of photons with different directions, with different probabilities, with different photon numbers and different modes. Then you don't have all the complete information about this mixture state, this statistical state. And then this is known as the mixed state. So I want to write the example. Thermal state means black body radiation. A thermal state of light is a common example of mixed state. For example, a light emitted from sun or some other heated object where the light is a mixture photons. Number states with different probabilities. It should be noted that thermal state or thermal light does not have a well-defined phase or photon number, but is distributed but is described by a distribution. For thermal light, the density matrix must be written as n is equal to 0 to infinity, and n average of n 1 plus n average n plus 1 and nn. So this is a mixture of Weber quantum state. So the density operator, some complicated one, and it can be represented by this. So this is the average, and this is the average number of photons. Light from sun or light bulb. More, we can explain this more an easy way. Let the light, the light emitted by a classical source is in thermal state. We do not know exactly that how many photons are in each mode, are in each mode at any time t. So it means that the system is in probabilistic mixture of different photon number state. So to summarize this, we have a pair state and the other one is a mixed state. In a pair state, we know about the quantum state, and the example of the photon number state, Fock state. If the coherent state is also a pair state, because Coherent state means if you have a laser light, then the laser light, you know the amplitude and phase, and these are in the phase, the frequency and all these are in phase. Then we can say that we know about the quantum state, and this is a power state. The squeeze state and the other some entangled states, we will discuss this later, but these are also a power state. And what is the mixed state? The mixed state is there we don't know about the quantum system, but we know about the probabilities of the power states. And the best example of the mixed state is the sunlight or some ordinary light from a bulb. And from this we don't know about the number of photons in each mode in any time t. So for this we can say that mixed state is different with a power state. Noted that for a power state we can write the density operator like this. And then from conservation of probability, the trace of this density operator, trace means we can convert this like this, and this is equal to 1. So this is for a power state. And if we take the square, rho square, then rho square means psi, psi, psi and psi. And this rho square, which is equal to psi, and this is equal to 1 and psi. And take the trace of this will be equal to psi, psi, which is equal to 1. So the trace square will be equal to 1. And what is the trace? Sum of diagonal elements. Sum of diagonal elements when this is equal to 1, then we can say that this is the trace. Physically, the trace means the sum of diagonal elements. And similarly, for a power state and for a mixed state, we know the probability p psi and psi. And if we take the trace of this or square of this, if we take the square, then psi, then phi, some other probability p psi and p phi, and then this is equal to psi, psi and phi, phi. And if this is equal to delta psi and phi, and if these are equal, then the value will be equal to 1. Then we can say that this rho square, which is equal to summation psi and p psi, if phi and psi are equal, then this will be equal to p psi square, and this will be equal to 1, and we have psi and psi. And if we take the trace of rho square for a mixed state, then we must have the form psi and psi, and this trace of rho square, this is equal to 1, then this is the probability p square, and this must be equal less than 1. The probability square must be less than 1. So this is the condition.